Hello and welcome to another The Future is Now edition, this time with another face who's no stranger to Elektor, Peter Dalmaris, expert on KiCad. How are you, Peter?
I'm good, Ryan. Good to see you in person.
Yes, for the first time in person and
Yeah.
all the way over from Australia. How's the jet lag treating you?
We've been here for a while, so no jet lag. It's so good.
Yeah, you didn't come alone. You brought the whole family, did you?
The whole catastrophe. Yeah.
Cool. So, yeah, we have an opportunity for you to show us live and in person with an audience here how KiCad is going up to version 8 now. And but before we get in depth at all, please tell us briefly about the basic functions of KiCad, what makes it different to any other commercial CAD program.
Yeah, sure. Thanks, Brian. So KiCad is not new. Probably KiCad, since I started working with it back in 2014, back in say 10 years ago, it was already version 4. And before that, KiCad had another 20 years of history behind it. So it's quite a mature product. In the early days, of course, it was an open source effort. It was a small number of contributors, open source contributors from around the world, trying to put a product that in the beginning would appeal to hobbyists. But over the years, as KiCad has been growing and its use base has been growing and its developers team has been growing. And now we're talking about, say, 100,000 users or more around the world. It's become a product that can be used not only by hobbyists, but professionals as well. And I know of professionals and small and large companies that use KiCad internally to produce products that go into electronic devices that we use every day. And if you go to the KiCad website, I can show you a few things here. If you go to the
if we could bring the presentation
website, up, you can get a sense of the kind of projects that are being built. So that will give you a sense of the power that this application has. So here's the KiCad website, and you can go to, let's see, where is it? Help. It's somewhere that's got project. Here we go, contribute. So somewhere here, I'll find it. About maybe somewhere here, you'll find projects. I'll keep looking as I'm talking. So made with KiCad, that's what I'm looking for. So now let's switch over to some of the benefits that I see in KiCad. Obviously, it's an application that you can use to build printed circuit boards. And it is fully open source, which means that you can see the source code, you can modify it, you can see what's in it. And for many of us, it is totally free. It's always been free, and it will continue to be free. Now, it's got many benefits, and I've got a blog post here where you can learn about all the things that I like about KiCad. I'm not going to go through all of them because it is quite a big discussion. Actually, this one here, why learn KiCad? But just in a summary, what I really like about KiCad as opposed to other applications is that, of course, it's free. It is unlimited, which means that it doesn't really matter how big your project gets. You can do it in KiCad. If you look at, for example, one of its metrics, let's go into KiCad settings. That will give you a sense of what you're looking at. If you go, oops, actually not that. I'll go in here. You can see that you can go all the way to 32 layer PCBs, which is massive. Okay, so that's one part of it. Other things that I really like about KiCad is that in the last 3 or 4 years, its release schedule has become very predictable. So it's almost as a tight controlled release cycle that you expect from larger companies with good funding. KiCad releases a new version every 1 year, and they've been able to pull that off for the last 3 years in a row. So from KiCad 5, 6, 7, and 8, and version 9 is coming out early this year. And that brings me to yet another thing that I really like about KiCad, and it is very transparent. So there you go. I'm clicking through these tabs because I can't really see them. It's so small on my screen. So anyway, this is an example of how KiCad's releases are predictable. You can just go to GitLab, and you can see version 9, 77% complete. and it's got a target due date of March 2, 2025. So I'll be waiting for the date to come. Not only that,
So put that in your calendars, March 2nd, 2025.
You can see what's going on in the background. This is all live, by the way. This is just like up to the minute. You can make your own requests. You can't really do that with commercial applications. So these are, I don't want to make this drag for too long, but these are some of the things that I really like about KiCad. You can do everything open source, predictable, and free. For many of us who are hobbyists, that counts quite a lot. So yeah, that's just a few things about KiCad. Now maybe I can also talk very quickly about the components of KiCad.
Yeah, sure. And you should know that Peter is no stranger to KiCad. He's a publisher with us. That's one of his books, KiCad Advanced Projects and Recipes. And then you've got KiCad Fundamentals and Projects. And these are thick books. So kudos to your discipline for getting these out there.
I wrote my first, the first edition of KiCad Elektor Pro for KiCad version 4. And the second edition came out about 3 years later, because at that point the team was still transitioning to its yearly release cycles. So I was able to just produce a book and then wait for 3 years and not worry too much about it until then KiCad 5 came out. But since then, they've been releasing every single year, showing how the project really is on rails in a way now, and they know what they're doing. That caused me a huge dilemma, because then I had to update the book every year, which is it's just not easy. That's over 1,000 pages. Anyway, back to KiCad. So another thing that I want to point out about KiCad is that it's not just one application. It's more like a suite of applications. So you can see this main window right here. Just make it a little bigger. It's composed of a bunch of individual applications. So of course, the main two applications are the schematic editor, which is where you can do or create your schematics. And then you've got the PCB editor, where you actually create what eventually is going to become the physical PCB. I'm just going to pick this. I'm just going to wave it. There you go. So this is just a panel with individual smaller PCB boards. I got this from Next PCB, and they asked me not to break it, because actually it's got 9 PCBs here, not just one. But this can actually be designed in the PCB editor. By the way, this is like a 12-layer PCB, high density, lots of SMD components in it. Pretty super duper PCB in other ways.
Bring that up on screen. Sure. That is pretty high density, yeah.
Yeah, 0.01 millimeter vias.
Wow.
Yeah, I won't get into that. Now, back to KiCad. So you can see there's a bunch of other applications here. There's editors. So this allows you to create simple editors. Now, this was a very important component of KiCad in the olden days, because libraries were kind of hard to find. So when I used to create my PCBs back in, say, 2015, most of the time, a component that I wanted to use was not available in the libraries, so I would have to create it. So I had to go to this little application or sub-application and make it in here. These days, there's just an abundance of libraries. And even this morning, I learned that someone out in the open source community created a library for Elektor. Hold on, I'll just go in here for Elektor. So all Elektor projects now have a library with its components. It's right in here.
Yeah, I found that out today as well. That's quite impressive, because Elektor does have a specific style for circuit diagrams. And someone has replicated it and called it Elektor, which is the original name for Elektor back when they started in the Netherlands back in 1961.
Yeah, could be one of your oldest fans out there. So yeah, so the interesting thing is that because of the popularity of KiCad and the community getting bigger and bigger, let's focus on the library part. I'm having trouble remembering how this tool works because I use it rarely now. So that's good and bad. There's also a footprint editor. So it's another application that you can use to create components like this, right? Although there are libraries that you can use, and those libraries also become pretty widespread and easy to find. There's things like Gerber viewers. I'm going to talk about this a little later. There are image converters, so you can have nice graphics on your PCBs. You can use this tool right here. So you can convert an image or a graphic into a silk screen or a copper type graphic. So you can decorate your PCBs. Calculators. Oops, not that. Where's the calculator? Yep. There's a calculator right here. So you can do some basic Ohm's law calculations, resistors, electrical vias, sizes, and truck widths. You can plug the numbers in here, and the results come out, and so on. Now, another interesting thing, and that is new, relatively new, and it has really released the creativity of the community, is the plugin editor and the plugin and content manager, I should say. So this allows anyone to extend the functionality of KiCad. If you know a bit of Python, then you can use the KiCad API and create sub-programs or small apps that can extend functionality. Not only that, but you can also package together things such as libraries and themes. So libraries for schematics and for footprints, and the color schemes and color themes to customize the look and feel of KiCad running on your computer. But back to plugins, this is just Python. This is just a selection of available titles. PCBWay plugin. You can order your plugin. You can order your PCB directly from the KiCad environment.
Nice.
There's one. There is another one that I use a lot. Is should be actually going to install. It will be easier. You find it right here. So interactive HTML BOM, so a bill of materials. There is the HQ DFM, so designed for manufacturing. I use this a lot because it runs a bunch of tests that allow you to see if there's any defects on your PCB that would affect not so much the functionality of the PCB, but the way that it is produced at the manufacturing house. So that is a test in addition to the test that KiCad itself can do. So I'll just give you an example of what that particular PCB looks like. Let's go in here. So by the way, this is one of the projects in this particular book here. It's a customized version of a ESP32 board. And I've got a few customizations in here that were appropriate for my projects. No problem at all. So I can bring up the HQ DFM plugin, comes up as a window, click on the button. It will do its tests in the background, and then it's going to give me a list of defects or alternatively check marks that everything is good. Takes a bit of time. I'll leave this run in the background. So I hope that this gives you a little bit of overview of what KiCad is, a collection of applications. There you go, succeeded. So yeah, wherever there's a red, you can see there's an issue that I need to address. So hole diameter here is probably below the minimum that I've set. Ring hole, same thing, no errors detected. And you can do, let's say for here, you can do a check and you can get some more interactive results about the test. It tells you where the problem is specifically. So I can click on this defect, for example, and it can just focus on exactly where the problem is. So I can see this pad is too close to this route. So I can fix that, rerun the test, and make sure it's cleared. So electrically, this board is fine. But when I sent it to the manufacturer, this proximity between the pad and the track could cause manufacturing problems. So this tool tells me about it. So these are the things that make KiCad progressively more competitive with very, very expensive other tools from the rest of the market. So I can continue talking about this, but I'll come back to you, Brian.
Look, it's a lot of applications and can be perhaps overwhelming for a beginner. Where would an absolute beginner start? For example, would you be able to take us through a simple board with a switch and an LED?
Yeah. So if you're just starting with KiCad, obviously you want to learn the basics. And I assume that you come from an electronics background, so you don't have to learn about like the basics of electricity and circuits. So the idea there is to learn the very few capabilities and buttons and features of KiCad to allow you to do something basic. For example, I'm going to quit and close this project, close a few windows that are not needed, and go into my book projects. I'm going to show you two things, actually. The first one is for the book project. Let's see. Maybe this one. This project here is pretty good. Right. So this is one of the first few projects in the book because it is a single, or sorry, it's a relatively simple schematic. It contains mostly passive components and a couple of regulators here, but nothing fancy. The whole point here is to learn how to create things like this, how to use, for example, labels. So here's one label, right? Here's another label. We use these labels to connect parts of the circuit together without using wires, because the more wires you use, the more cluttered the circuit becomes. So beginners tend to go for wires because the symbology doesn't make sense initially. So then slowly we go through using symbols instead of wires. So learn the process of doing all this, finding the components from the editor here, or the chooser. So how to find what you need from the libraries, maybe how to install a new library into KiCad. These days, this is very easy, so we'll go through that fairly quickly. Now, how to drop a component. Actually, I'll do that again. How to drop a particular component onto the editor, and then start wiring. Oops, I'll just start creating some wires. I use shortcuts for this, like this. Basic stuff. I'm just going to delete it now. From here, how to switch to the PCB editor. Show a couple of ways of connecting pins together. So manual connections for small circuits. We start with manual connections. Then we introduce the auto router. So as your project's becoming bigger and bigger, routing is very time consuming. So we can get the auto router to do at least the first pass, and then we can manually use some magic that KiCad has introduced lately in its PCB editor to make manual routing fast and high quality. And then that would the last step would be from here to go to the actual printed circuit board. So how do you export a file that contains all the information that the manufacturer needs in order to produce a final result? So we've got a plotter. This is another way, another place where KiCad has improved lately, is that it allows you to export your PCB in a variety of different files. So Gerbers is the most common one, but another thing you can do these days is to, I haven't got the proper plugin here, but you can go, I'm just going to show you, you can go back to the plugin manager, and let's pick this one here, for example, HQ PCB. You don't even have to export a file. You can just install something like this that various manufacturers have. It's a plugin that integrates your KiCad environment with a backend. So you click on a button, and you can literally order from within KiCad, so you don't have to leave the environment. So that's just, for a beginner, understanding this workflow is the key to understanding KiCad itself, because this is done slightly differently to how you do the same thing in other applications, especially if you're coming from, say, Altium. Things are done differently there. So learn the workflow, and then you can go ahead and create your first PCB. There's really not that much more that you need to know in order to get started. Like, you can ignore most of the buttons here. You can ignore most of the buttons here. These are kind of more fancy features and capabilities to improve efficiency over time, but you don't have to worry about any of that when you get started.
So you start at schematic. On the very earliest CAD programs, you went straight to board design. Is there a bit of automation in getting the board designed straight from schematic to board design?
No, I wouldn't call it automation. This is still a manual process. So in the book, I provide kind of a blueprint of how you can have a bunch of components that at the beginning, they kind of randomly spread out in your editor. When you come with a in a blank PCB editor, there's no particular order. The components tend to be grouped together, but then it's up to you, the designer, to put them in a sort of order that resembles what the final PCB is going to look like. So you, as a designer, you need to know what you're targeting, what you're trying to build. So in other words, you kind of need to have something like this in your head, in your imagination, right? So this is, I'm just going to click out of that so you can see what this looks like. So this is a 3D rendering of this board. But when I start designing a new board, I have a physical board in my head. Sometimes I just use pen and paper and I draw some draft of what it could look like in 3D. Now, this particular case, I've got some restrictions because this is supposed to be a power supply for a breadboard project. So my main requirements here is that these two pin headers need to be in the right dimensions to plug into a standard PCB. So I've got that in mind, and I start my design literally from these two headers. The rest, I just try to make it reasonably, reasonably placed so that I've got the power components right here. You can see I've got these two regulators right next to the power plug. I've got an LED. I've got another set of headers here to allow me to switch voltage. This is like the user interface of this particular PCB. So it really all depends on you as a designer. Now, Brian, another thing that I am hoping to see in the future from the KiCad project is more this type of automation that's powered by AI. And I've seen that happening in a few tools that I've seen online, where you can literally say to a AI assistant that you want to build a particular type of PCB and ask for advice. What kind of components should you use? You can ask it to create, for example, a layout that would resemble, say, a breadboard, or you can plug into a breadboard. So you can start getting assistance from artificial intelligence tools. And I believe Altium probably does something like that. I was talking to a representative a bit earlier today. And I hope that in this year even, I'm going to come back to the the plugin manager, and I will see a plugin for this exact purpose, to help out, speed up, and improve efficiencies. So for now, this is a manual process.
Yeah. I'm going to go to the online chat quickly.
Sure.
We've got our old friend Frank de Hat, who just can't stay away. Harry Kunter says hello from the Black Forest. Mihai says hello. I'm going quickly because we have a time limit. Enrique Bernal, hello from Spain. Build Your CNC says hello all. He has a contentious issue. Build Your CNC says, I am happy to hear the developer pronounce KiCad, not I can pronounce it correctly. Well, you know, when I first saw KiCad, I've seen Wi-Fi, I've seen Hi-Fi, so I thought it was KiCad, but apparently it's KiCad.
Yeah, I don't think we're ever going to get a consensus on this. Yeah, I've switched both pronunciations. I'm still not sure which one's right.
And then Frank asked, is the auto router integrated or is it a plugin?
Yeah, it's a plugin. So the one that I use is over here. This one here. Yeah. Unable to export. Sorry, could be not. Not sure what's going on here, but yeah, it is a plugin. So it is a plugin. It it allows basically to auto route without having to leave the KiCad environment. So it's all integrated these days. It feels like it is part of the KiCad environment. So you don't have to create net lists, export, and then import into an external auto router.
Great. And are there any questions here on the floor? Let me hand you over. I'm going to leave the picture, and you at home won't be able to see the audience, but I'm going to hand the mic to DIY guy Chris, who's right here.
Thanks. That's okay. I would say that's great presentation. Thank you for all what you're doing. It's awesome. I have just a quick question about the possibility to integrate something that allow users to make a Gerber generated out of colorful silk screen circuit boards. So out of the classic circuit boards colors, like a silk screen is green or blue or red, there's now a possibility to produce a customized circuit board while the silk screen is a customized colorful image. And you already have an example in front of you, right? Behind your computer. Yeah, that's the circuit board.
Oh, this one here. Yeah.
And I don't know, maybe if you're considering adding this or not, because it requires a specific Gerber, specific file formats and the Gerber files and the generated Gerber files. But the ECAD tool has to allow uploading colorful images in a PCB design at first. And another question is for the DFM. I tried an external DFM once from a PCB manufacturer. They are having a DFM service, and I noticed that the DFM allows to track up to only 20 errors. So you have to fix these errors and check again to spot new errors. Yeah. I don't know if this is the case for your integrated DFM or not. From one shot, it detects all the potential manufacturing problems, or you have to fix and reload. So that's that. Yeah.
Okay. For your first question, I don't think KiCad can do this at this time. This is pretty cool, but I haven't seen anything that suggests that KiCad can do it. So maybe a different version. I'd be very interested to know how Elektor did this, because yeah, it's very interesting. For the second question, HQFM, yes. So I have used basically this tool here quite a bit, and I also talk about it in my book. And also the plugin version of HQDFM. The plugin version is the one that I spoke about earlier. This one here. Yeah.
That's the one I used already, the HQDFM, yeah.
This one does have limits.
Yeah,
right?
Exactly.
It is probably the first pass. Because it is a plugin and it's integrated into KiCad, I go with this one first. Once I have green for everything, then I can bother, essentially, to use this free or standalone application. This is a standalone application, so you have to export something from KiCad in order to import it into the standalone tool. And this is obviously a lot more powerful. And it even gives you a full PDF report that you can, I guess, share with your team. And yeah, no limits in this one. And I believe that this is also going to be customizable. Maybe it is already customizable. So you can use it not just with HQDFM as a manufacturer, but with other manufacturers as well.
Great. Thank you. Thanks.
DIY guy Chris in the house. Any further questions from the floor?
Hello, thank you for your presentation. I have a question. Is it possible to import circuit diagrams as well as boards and devices from Eagle?
So if I heard right, to import circuit diagrams or schematics?
Yes.
Yes, it is possible. So KiCad has the ability to import projects. You can see here, import non-KiCad projects. So right now, CADStar, Eagle, Easy EDA are supported. If you go also into the schematic, I'm just going to clean up a little bit here. So cancel discard changes. Yeah. So I'm now looking at the schematic. So you can see this import non-KiCad schematic as well. So you can import projects from other tools or specifically schematics. So if I go in here, non-KiCad schematic, yeah, that's a warning because I already have something in my schematic. Let me just say no to this. Hold on. Discard, close, project, and start a new one. Sorry, Baron, just really quickly. Let's go for, actually not that. Let's go for a new project. Untitled. Yeah. So you go into a blank schematic and import non-KiCad schematic, and you see a few options down here as to what it is that you can import. So these are actually, for example, you can see LT Spice down here. This is a circuit from the Spice simulator. So there are ways to import projects from other tools or schematics or even just PCBs.
And the devices too. The symbol and the footprint is called the device at Eagle.
Footprint?
The footprint. No, the symbol and the footprint together is a device. It's called the device at Eagle. And the library has many devices, also my own devices. And of course, it would be very important to further use the devices I designed for Eagle here together with KiCad.
If I heard right, you're saying to be able to import a library from Eagle into KiCad. I'm not sure about that because KiCad has its own kind of native protocol for libraries. So I'm not sure if such type of import will be possible. What KiCad does in the background is try to match a symbol, for example, from an Eagle project into a symbol from KiCad. So I'm not really sure if third-party libraries from other tools can be imported into KiCad, but that's something I've got to look into.
Okay, thank you.
Not if it's answered that.
Okay, any other questions? Well, that's good. No further questions because we've just about run out of time. Peter, I'd like to thank you once again for coming all the way from Australia, not just for this show, obviously, but to see the fantastic expo of Elektor and others at Electronica 2024. Thank you for everyone joining us around the world as usual. The chat is busy, and thank you for the audience right here in front of the stage. And thank you, Peter, for joining us.
Thank you, Brian.
Goodbye.